Hello everyone. Today we're going to talk about a concept that very often puzzles trigonometry students. To talk about this concept, let's first of all do a brief bit of review. First of all, we have all students take calculus. You know that that's a memory device that we very often use here in trigonometry class to remember in which quadrants our ratios are positive. So I've taken the first letter of each word in this memory device, ASTC, and I've used it to fill in going counterclockwise, ASTC. Here in quadrant 1, if your terminal side of your angle is in quadrant 1, all ratios for all 6 trigonometric functions will be positive. However, in quadrant 2, between pi over 2 and pi, only sine and its reciprocal cosecant will produce positive ratios. The other 4 trigonometric functions will produce negative ratios. Between pi and 3 pi over 2, only tangent and cotangent produce positive ratios, and between 3 pi over 2 and 2 pi, only cosine and its reciprocal secant produce positive ratios. Now that's typically true. However, when we cropped the graphs of our 3 favorite trigonometric functions, sine, cosine, and tangent, we restricted those graphs so that they weren't represented in all 4 quadrants. When we were done cropping the graphs, we found that if we had a positive ratio, it was because the terminal side of our particular angle was between 0 and positive pi over 2. Now this is where things get tricky. If we had negative ratios, where were those produced? Well, in some instances, they were produced by an angle between pi over 2 and pi, and that was only if we were talking with respect to the cosine, the inverse cosine function. That would produce a negative ratio if the terminal side for cosine, the inverse cosine, was between pi over 2 and pi. For sine and tangent, however, if the ratio is negative, it has to be produced by an angle between 0 and negative pi over 2. Where did this negative pi over 2 come from? Well, if you recall, when we go clockwise, we name our angles as negative angles. If we go counterclockwise, our angles are positive angles. So therefore, I'm going to call these angles between 0 and here in quadrant 4, those angles are going to be angles between 0 and minus pi over 2 radians. Now let's try 4 problems from our textbook that take into account these complex trigonometric functions. And the first one of those asks us to find the inverse cosine of the cosine of 2 pi over 3. Now you'd think this would be pretty simple. If the cosine of 2 pi over 3 produces an angle, and produces a ratio rather, and then I take the inverse cosine of that ratio, wouldn't it produce an angle in quadrant 2 pi over 3? So wouldn't our answer be 2 pi over 3? Well, it may or it may not be. First of all, I ask myself, where is the angle 2 pi over 3? And going up here to the top, I say the angle 2 pi over 3 is located in quadrant 2. Does cosine produce a positive or a negative angle in quadrant 2? Cosine produces a negative ratio in quadrant 2. If I'm taking the inverse cosine of a negative ratio, it will be produced by an angle over here in quadrant 2. So there is agreement, and therefore I say my answer is 2 pi over 3. That will be the angle. Is that always the case? No. We have to be really careful. In the second example, I have the cosine of 4 pi over 3. And I say, where is 4 pi over 3 located back up here? 4 pi over 3 would be located in it's an angle in quadrant 3. Does cosine produce a positive or a negative ratio in quadrant 3? It produces a negative ratio in quadrant 3. But we see if we're talking about an inverse function, there's nothing here in quadrant 3. Where else does cosine produce a negative ratio? it produces a negative ratio if its terminal side is here in quadrant 2. So what's an angle in quadrant 2, the equivalent of 4 pi over 3, that will produce the same numerical ratio, but actually exist in quadrant 2, which is where the inverse cosine is allowed to exist if the ratio is negative. And I say that's if the angle is 2 pi over 3, I'm going to get the same negative ratio as I would for the cosine of 4 pi over 3, but this is the only place that the inverse cosine is allowed to produce negative angles. Moving on to question number 3. I look inside and I see here that they want the ratio produced by the tangent of 3 pi over 4. Where does the angle 3 pi over 4 fall? Back up here. It falls in quadrant 2. Does tangent produce a positive angle or a negative angle in quadrant 2? Well, clearly it produces a negative angle in quadrant 2. Okay, so it produces a negative angle in quadrant 2, but now I'm looking for the inverse. And clearly in quadrant 2 we don't have a t. We don't have tangent producing a negative angle over here in quadrant 2. Where will tangent produce a negative angle? Only if its terminal side is here in quadrant 4 between 0 and minus pi over 2. What is an angle in quadrant 4 between 0 and minus pi over 2 that will produce the same ratio as 3 pi over 4, and that angle is minus pi over 4? Tricky. No? Finally, in question 4, they're asking me the tangent of a negative pi over 3. Where's negative pi over 3? It's here in quadrant 4. Does tangent produce a negative angle in quadrant 4? Clearly it does. Okay, so I can report the same angle here, which is minus pi over 3, because this angle produces a negative ratio, and clearly I'm allowed to have negative ratios over here for my inverse tangent function if the function is between 0 and minus pi over 2, which it is. This is a tricky topic. I want to wish you the best of luck in studying this. It can be nasty.